the age of the atom. That was the official announcement made by the American Department of Defense on July the 16th, 1945, following the detonation in a desert area of New Mexico of the world's first atomic bomb. Three weeks later, a second, and only 3 days after that, a third nuclear device was set off. The atomic bombs dropped on the Japanese cities of Hiroshima and Nagasaki in August 1945 brought the Second World War to an end. When German chemist Otto Hahn discovered nuclear fission in 1938, he had no idea of the implications of his discovery. At the time, science had thought it impossible to split the nucleus of an atom. Through his work, Otto Hahn paved the way for the nuclear age. Frankfurt am Main, where Otto Hahn was born in 1879. After obtaining a doctorate in chemistry, he went to London. Working at University College, he became interested in radioactivity and decided to make it his special field. Hahn left London for Montreal to spend several months researching under the most celebrated nuclear scientist of the day, Ernest Rutherford. In 1906, Otto Hahn returned to Germany to take up a post at the University of Berlin. 5 years later, he was appointed head of the newly founded Department of Radiochemistry. Hahn was joined at the department by a close colleague, Lise Meitner, an analytical physicist who came from Vienna. For 30 years, Hahn and Meitner formed an ideal research team. In 1896, French physicist Henri Becquerel had discovered that uranium emits rays which are radioactive. In 1911, Ernest Rutherford discovered that the positive charge in an atom, and almost all the mass, is concentrated on a tiny central nucleus, and that negatively charged electrons orbit about this nucleus. He also found that the radiation emitted by the nucleus consists of 3 components. 2 of them are rays made up of minute particles, which Rutherford named alpha and beta. The 3rd component is electromagnetic gamma radiation. Rutherford determined that radiation has a specific energy value, but he didn't know where the energy came from. The famous physicist Albert Einstein provided the answer. He reasoned that since matter and energy are essentially the same, they can also change into each other. In his theory of relativity, energy equals mass times the speed of light squared, he determined the exact relationship between the two. According to Einstein, part of the matter of a radioactive atom must have changed into energy. When uranium disintegrates into another element, part of its mass becomes energy and is released as radiation. The nucleus of an atom consists of positively charged protons and neutrons, particles with no charge. The two are held together by nuclear binding energy. What physicists wanted to know was whether the composition of an atomic nucleus can be altered. Uranium is the heaviest element that occurs in nature, but could an even heavier element be obtained from uranium? At the time, no one thought of the possibility of nuclear fission. Without realizing it, Otto Hahn and Lise Meitner were on the verge of a discovery that would change the world, but their cooperation was brought to a sudden end. In 1938, Germany annexed neighboring Austria. This meant that Lise Meitner, a Jewess from Vienna, came under the Nazi race laws. Her only hope of survival was to leave Germany. Otto Hahn used his influence to procure emigration papers for her. Lise Meitner sailed from Hamburg to Sweden, where she found a new, safe home in Stockholm. From then on, Otto Hahn had to get by without the analytical mind of his close colleague. In a letter to Lise Meitner, written in November 1938, Hahn told her of some strange results he'd obtained. Together with his assistant, Fritz Strassmann, Hahn had been studying the behavior of uranium atoms when they're bombarded with neutrons. He'd expected that the neutrons would make the uranium unstable and cause it to disintegrate into radium. A neighboring element of uranium, radium has 4 protons and 4 neutrons fewer than uranium. However, chemical analysis of the bombarded uranium showed it wasn't radium that had been produced, but barium. And barium doesn't have even half the mass of uranium. Hahn thought he'd made an error. He didn't know how to interpret the results of his experiment. He was undoubtedly the leading radiochemist of his day. Now Hahn had to apply 40 years of experience to try and unravel the mystery of the uranium nucleus. Totally baffled, on December the 20th, 1939, Hahn wrote to Lisa Meitner in Stockholm, "Perhaps you can come up with some fantastic explanation. Could it be possible," he asked, "that the uranium nucleus burst?" That Christmas, Lisa Meitner received a visit from her nephew, nuclear physicist Otto Frisch. Together, they tried to interpret Otto Hahn's findings. The nucleus of an atom is not a solid, brittle body that can be shattered. On the contrary, it's more like a drop of liquid. Lisa Meitner had an idea. A uranium nucleus that has gained a neutron, she reasoned, becomes unstable and assumes a shape like a dumbbell. Since they both have the same electrical charge, the 2 nodules repel each other with tremendous force. Separation occurs in the middle, and instead of 1 large nucleus, 2 smaller ones are formed. But where does the vast amount of energy come from? Energy is mass times the speed of light squared. If the 2 small nuclei together weigh less than the uranium nucleus they emerged from, then part of the mass must have been transformed into energy. So the mass of the nucleus itself is the source of energy. Hahn's experiments and Meitner's theory were soon confirmed by other scientists. In 1944, Otto Hahn was awarded the Nobel Prize for Chemistry for his discovery. But there was one thing Hahn and Meitner had failed to recognize. When nuclear fission takes place, it's not only energy that's released, but also neutrons. They trigger off more nuclear fission. When there's a massive multiplication of neutrons, scientists talk of an uncontrolled chain reaction. In 1942, Italian physicist Enrico Fermi produced the first controlled chain reaction. Controlled means that on average only 1 neutron per fission event is released. The fission process takes place slowly and energy is released evenly. Chicago Pile 1 was the world's first nuclear reactor. While scientists were trying to utilize nuclear fission as a source of energy, the Second World War was still raging. In Europe, Hitler was prepared to go to any lengths to secure victory. Consequently, the Americans were afraid of the Germans developing an atomic bomb. But émigré scientists in the United States were faced with a moral dilemma. Should they place such a destructive weapon in the hands of the Allied General Staffs? Hungarian physicist Leo Szilard wanted at all costs to prevent Nazi Germany from developing a nuclear device. In 1942, he met Albert Einstein and persuaded him to write a letter to American President Franklin D. Roosevelt describing the horrific consequences of an atomic bomb in German hands. Einstein's letter had the desired effect. Roosevelt launched the Manhattan Project, the biggest scientific and military research operation of all time. Under the direction of Robert Oppenheimer, 180,000 people worked on the construction of an atomic bomb. They included 14,000 physicists and engineers. The intellectual center of the project was the laboratory at the University of Chicago where Enrico Fermi was working. In peacetime, the bomb would have taken years to develop, but with a huge team working flat out to beat the Germans, progress was achieved at a much faster rate. On May the 8th, 1945, Germany capitulated and Europe was divided up amongst the victorious powers. But the war in the Pacific continued. The battered Japanese Air Force launched its last major offensive, inflicting serious losses on American forces. To bring the long conflict with Japan to an end, and in a way less costly to US lives than an invasion, American President Harry S. Truman decided to use the new superweapon. On the morning of August the 6th, 1945, an atomic bomb named Fat Boy was dropped on the Japanese city of Hiroshima. It exploded with a force of 20,000 tons of TNT. 3 days later, a second atomic bomb was dropped on Nagasaki. The two bombs killed 300,000 people outright. Hundreds of thousands more died months later as a result of radioactive fallout. Otto Hahn heard of the raids in detention in Britain. He was horrified that the atomic bomb had been used and felt partly to blame for the terrible suffering it had caused. In the 1950s, Hahn became a resolute opponent of the military use of nuclear technology. As initiator of the Göttingen Manifesto, he protested against worldwide nuclear tests. But developments could no longer be halted. The Cold War led to rearmament on a scale the world had never seen before. At the same time, however, hopes grew in the industrialized nations that the peaceful utilization of nuclear technology might provide a long-term solution to mankind's energy problems. Obtaining nuclear independence from fossilized raw materials became a national goal, because uranium seemed to be available in almost unlimited quantities. In October 1956, the first nuclear power station for supplying electricity on a commercial basis was commissioned at Calder Hall on the northwest coast of Britain. The euphoria was great, and in the years that followed, nuclear power stations mushroomed everywhere. Basically, an atomic power station functions like a conventional thermal power station. Steam drives a turbine, the rotary motion of which is converted into electrical energy by a generator. In a nuclear reactor, the controlled fission of uranium takes place. The thermal energy that is released heats up water in a pressurized vessel. This produces steam which drives a turbine. In order to protect the outside world from radioactive radiation, the core of the reactor is sheathed in a layer of concrete several meters thick. In 1979, the first serious accident involving a nuclear reactor occurred at Harrisburg in the United States. The cause, human negligence. Fortunately, the nuclear power station's safety system prevented a disaster. The worst nuclear accident so far occurred at Chernobyl power station in the Ukraine. A defective safety system and an incorrect response by the operating staff caused the fuel rods to melt. Radioactive radiation was released into the open air. Thousands had to be evacuated, and the region around Kiev will be uninhabitable for decades to come. Safety standards in nuclear power stations in Western Europe are much higher, but many people remain skeptical. With his discovery, Otto Hahn triggered off a development he could never have anticipated. 1938 marked the dawn of the nuclear age, an age that changed the world. In August 1945, brought the Second World War to an end. When German chemist Otto Hahn discovered nuclear fission in 1938, he had no idea of the implications of his discovery. At the time, science had thought it impossible to split the nucleus of an atom. Through his work, Otto Hahn paved the way for the nuclear age. Frankfurt am Main, where Otto Hahn was born in 1879. After obtaining a doctorate in chemistry, he went to London. Working at University College, he became interested in radioactivity and decided to make it his special field. Hahn left London for Montreal to spend several months researching under the most celebrated nuclear scientist of the day, Ernest Rutherford. In 1906, 3 weeks later, a second, and only 3 days after that, a third nuclear device was set off. The atomic bombs dropped on the Japanese cities of Hiroshima and Nagasaki, the age of the atom. That was the official announcement made by the American Department of Defense on July the 16th, 1945, following the detonation in a desert area of New Mexico of the world's first atomic bomb.